Alright, we're continuing our look at linear functions. Today we're focusing on one of my favorite ways to graph, and that is by using intercepts. So first let's just define what an intercept means. So I like to think about in football, if I have an interception, it's like the quarterback is taking a football, throwing it to a passer, and somebody else cuts it off. So that intercept is that point where it cuts off. In math class, the y-intercept is the y-coordinate where the graph intercepts or crosses the y-axis. And the thing to remember here is that the x-coordinate of this point will always be 0. Okay, so if we look over at the right here on our graph, remember our y-axis is always our vertical one. So at this point, our y-intercept is right here. It's at negative 120. So the point or the ordered pair would be 0, negative 120, because that's the point when our line is crossing the y-axis. At the same time, the x-intercept is the same thing, except for it's the x-coordinate where the graph intersects the x-axis. And here, the y-coordinate of this point is always, I hope you can guess it, 0. So on our graph, in our example, our y-intercept, or our x-intercept is 4, and the ordered pair is 4, 0, and that's the point where it crosses the x-axis. Alright, so here we have a picture of a graph. I want you to just see, without me modeling it first, just pause the video and see if you can figure out the ordered pair for both the x and the y-intercept. Alright, when I look here, I'm going to draw a point just so you see. So here is our first point, here's our second point. So we're looking for where they cross the axes. So remember, our x-coordinate is always first, so our first point I'm going to look at is right here. The x-coordinate there is negative 2, so for our x-intercept, it's negative 2, and the y part is simple, it's always 0. For our y-intercept, that's this point right here, our x-coordinate is always going to be 0, and my y-coordinate in this case is going to be positive 1. Now we're going to see how this actually applies when we want to graph. One way we're going to do that is we're going to be given an equation in standard form, in this case 5x minus 2y equals 10. We're going to use that equation to find the x and the y-intercept because that gives us 2 points that we can then graph. And the nice thing about this is because it's intercepts, we're always working with zeros. Zeros are super easy to work with because they're easy to multiply and they're easy to add. So first I'm going to find the x-intercept by replacing y with the 0. So 5x minus 2 times 0 is equal to 10. Well, that 2 times 0 is just 0, so it becomes 5x minus 0, which is also just 5x, equals 10. Divide both sides by 5 to isolate our variable, so x is equal to 2. So my ordered pair is 2, 0. And once again, that's going to be my x-intercept. Now I'm going to pause the video, or I'm going to encourage you to pause the video and try to find the y-intercept by yourself and then check your work. So here it's going to be that same type of idea, except for now I'm going to put 0 in for x. So it's 5 times 0 minus 2y is equal to 10. Once again, 5 times 0 is 0, so it becomes 0 minus 2y, or we leave it a negative 2y equals 10. I'm going to divide both sides by negative 2 to isolate the variable. So y is going to equal negative 5. So my coordinate is going to be 0, negative 5. And remember, I know that it's 0, 1 because when it's an intercept it's always 0, and 2 because that's the value that I substituted in for x. Now let's look at a real life example. If Trish can run the 200 meter dash in 25 seconds, the function f of x equals 200 minus 8x gives the distance remaining to be run after x seconds. We're going to graph this function and find the intercepts, and then talk about what does each intercept represent. Now, I'm going to give you values for x, but realistically, you could always pick your own values. But in this particular situation, it's important to note that neither time nor distance can be negative. So we're only going to choose non-negative or positive values for x. In this example, we've used 0, 5, 10, 20, and 25. Well, when the time is 0, she still has 200 meters left to run. After 5 seconds, we would do 8 times 5, which is 40. So she would have 160 because we would have done 200 minus 40. At 10 seconds, she would have run 80 meters already. So 200 minus 80 gives us 120. At 20 seconds, she would have run 160. So we would do our 200 minus our 160, and we'd have 40. And then after 25 seconds, she would have run the full 200 meters, so her distance left would be 0. Now even here from our graph, we already know what our intercepts are. Notice here my x value is 0, and on this last one my y value was 0. So remember, our x-intercept was not 0. It was 25, 0, and our y-intercept was 0, 200. So now we can graph those ordered pairs. Now notice all of the ordered pairs have actually been graphed here, but here is my y-intercept, here is my x-intercept. These in-between points just kind of serve as a good checker to make sure that we are looking at that linear function. So I'm just going to go ahead and connect those dots. Now here, we don't actually need the arrows at the end because we can't have negative values, so it's never going to extend past this point or past this point. So let's just talk about what these mean then. So here with our y-intercept, let's start with that one because that's furthest to the left. That would be meaning that at 0 seconds she has 200 meters. She hasn't run at all. Then at 25 seconds, that would mean that she has finished the race and has no distance left to run in her 200 meter dash. Alright, let's try another one. So once again, I'm going to encourage you to pause the video, try this out without any direction from me, and then just check your work. So here we have 3x minus 7y equals 21. So remember, for our x-intercept, we're going to put 0 in for y. So if it helps you, y equals 0, x equals 0. So it's always 0 for the opposite value in the coordinate. So here, the 7 minus 0 cancels out. So now I just have 3x equals 21. Divide by 3, so x is equal to 7. So my ordered pair would be 7, 0. Here my y-intercept is going to be 3 times 0 minus 7y equals 21. Negative 7y equals 21. Going to divide by negative 7, so y is going to equal negative 3. So our ordered pair is 0, negative 3. Well, now that we have our intercepts figured out, we can actually use those to graph. So if you remember, we had our x-intercept was 0, 7, and our y-intercept was, oops, I skipped, flip that around, hold on. Our x-intercept was 7, 0, and our y-intercept was 0, negative 3. So we can go ahead and graph those. So we would go to the right 7, and then we have 0, negative 3, and then we're just going to go ahead and draw a line between those 2 points. Now this one we would have the arrows on. Now, we're not always going to get an equation in standard form, so if we get an equation that's not in standard form, the first thing we want to do is change it into standard form. So in this case, we want to get x and y on the same side. So if y is equal to the opposite x of plus 4, then go ahead and add x to both sides, and then I end up with x plus y is equal to 4. Now that I know that x plus y equals 4, I can find my x and y intercepts. So here, x plus 0 would equal 4, and here 0 plus y would equal 4. So our x-intercept is going to be 4, 0, and our y-intercept is going to be 0, 4. Same thing, we can go ahead and graph those 2 points. Draw our line. Hopefully you're doing that with a ruler, so your line is a little bit straighter than mine was. And go ahead and draw our arrows at the end. Now you can go ahead and get started on your homework. Let me know if you have any questions.